Alright, we're GeMAC. We're recording for the cardiac artery disease. And we have a couple of sensors. First we go. We're going to talk about, first we're going to talk the introduction of our product. What we did to achieve it. We're going to talk about hardware, database, software, user interface, and we're going to give a live demonstration. First, we want to create the sensors. We want to show it on the screen, because if you show it, it's always good to see. So we created, we created the web app to see all the information. We try to give graphs and an overview so you can see if there's a patient and if there's something wrong. Yeah, you should see it. Now, our business case, we want to create a platform for a doctor, physician. Yeah, so when he something wrong with a patient, you need to see it quite fast. For instance, if a patient has a heart attack and he scanned a strange value, the physician receives a message in red on the screen. This patient needs help right now, and you can see it on we will see it later on. We created a web app, as I told. It's on the website of IVA, so we can show it online. There, all the data in the database is saved, and when the patient is scanning information, it gets saved there.
We wanted to create a whole infrastructure with Team Germany 3, but I'm not sure if you can see that.
Yeah.
No. Okay, then I just talk about it. We had our agent, which is our Raspberry Pi, with the sensor chip from the Arduino. And our goal was to get a connection to the manager of Team Germany 3. This didn't work out because we had some problems yesterday, like a Black Wednesday. During our working, we had a file system crash, so our whole work is... Our partition was corrupted on the Raspberry Pi, so we had to fix that a long time. But now we are back, but we can't show it directly, so I show a demonstration of the interface, which we had implemented on the agent. Before there was no interface, so you couldn't control when you want to measure or what you want to measure. So we implemented that, and you cannot see that, but we implemented the agent interface and the web app, which is getting the data from our web server. And we had a plan to implement some maintenance communication between the device and the company who's creating the device, because the whole infrastructure is made about open hardware. So every company who wants to get in this business can join us. So it's all these open standards like X73 from Team Germany 3 and HL7. So everyone who wants to create an agent can create an agent, just use the standard, connect to a manager, and the data is pushed via HL7 to the database of the hospital, of the physician, or where else. Yeah, that's what we had planned, but it didn't work out. So everyone is told about the Raspberry Pi. We used the Wi-Fi demo now to connect to the Wi-Fi. And we added a temperature sensor, which was not implemented yet. And yeah, to the database, we changed the database.
Okay. So the original idea from the Austrian group was to gather all the data, save it to a file, send it to the server, then push it to the database. What we did is rewrite that whole part of the system. So now we have a local SQLite database on the Raspberry, which enables us, well, now we have an index storage. This enables us to query the data even if we don't have a connection and we didn't synchronize it with the server. Then, whenever we get a connection, so on regular intervals, we ping the server and synchronize with the main server. We also extended the model, so now we don't save each individual measurement anymore, but we introduced the concept of measurement session. So we gather multiple measurements from different sensors, and from that, in future, I mean, if we had more time, we could do it now, but in the future, we could like extrapolate patient status from all that data and just push it to the database so that the physician could see it. Okay. Okay, so this is the database model. I'm not really going to go deep into it. I think that would be it.
Yeah. More about the user interface we developed for the Raspberry Pi. We used C++ with the Qt framework for designing and implementing the interface. On the ancient PHP we used to develop the web app. I mean, that's common. So this is how our smart app or user interface looks like. We have a main screen where you boot up your device, you get to this main screen. You can select which measurement you want to make: airflow, pressure, temperature, pulse, ECG, glucose. We used simple icons, so even older people who can't read small fonts or something can use them because they're easy to remain. Like how hard is a pulse, square is a sugar square, so it's easy to remember. And that's just some screens when you're recording your data and when you're going to server. I'll show you a quick demonstration. Because we have some nice features. Thanks to Simran, we have a really nice voice, which is close to, how's it called, Siri? But it's much nicer. So, it's awesome, so you're gonna hear it now. So, we boot up our device.
Hello and welcome to GeMAC.
So the device we have some animation here to see what's going on. So the heart is beating, we go into GeMAC and you get the signal out. So we now can select the type of measurements you want to do, like you're recording pulse now.
Please wait until your data is recorded.
So it's just a demonstration because we make the measurements, that's why it's so quick. So the progress bar is filling as long as the measurements takes place. And when it's done, the button raises up and says, okay, it's complete.
Please wait, data will be uploaded.
So then it takes another step, data is uploaded, if possible, if the Wi-Fi connection is there. And then
Upload is now complete.
that's it. Yeah. So we created a web app, or extended it.
We extended the web app. We chose to give the physician an overview of all the information. We created a couple of status. For instance, it's okay, give a warning. There need to be the maintenance, so the physician knows if the product is still okay. It probably functions. So I can show you online. Here you have the overview. This is what the physician will see. The physician can click, for instance, on Hans. Well, because Hans is red and there is something wrong with Hans. And the physician needs to check on it. So he clicks on it. We also wanted to create some graphs. Unfortunately, it crashed also this morning.
Sorry.
There were some deleted parts of the page, so nothing will load on it. All the information is shown here. You can see some measurements, for instance, from the airflow in front of it. The airflow, electrocardiac, the glucose, and all the measurements you already saw in the application from the which is sent from the Raspberry Pi. Here's, for instance, one of the graphs. You measure every day for it's a template that right now to show something. We have a max value. If you have a glucose level above the 240, it's unhealthy, and you receive a red mark on the physician overview, and the physician knows there is something wrong and he can check into the patient. That's our presentation, and we are open for questions.